as Felipe said, my name is Juan Pablo Tosso. I'm the author and co-leader of the Coraza project. I have been working in cybersecurity for the past 10 years. And, I live off an API security and pen testing. You already know Felipe, but CRS co-leader, Coraza co-leader, and a huge long-term supporter of OWASP projects. Co-leader of 3 projects. We're going to perform a deep dive into the lifetime of web application firewalls and through the internet. So if you all remember the 90s internet, raw HTML websites with fancy backgrounds, nice cursors and background music. So we used to consume the HTTP 0.9, which also only supported the GET method. So applications weren't really rich. There wasn't much to do. There wasn't a lot of scripting that you could perform. And there were tools like ActiveX that you could use to improve your web applications with some rich content. And, well, Netscape was a real deal. So the story of WAFs starts with AppShield. They were the first team that created the concept of web application firewalls. The idea was to parse HTML and process request and response. It supported headers. It's basically the same concept we have today, but it was the first attempt, and the project managed to live for more than 10 years. Right now it has disappeared, but mod security came trying to achieve the same as AppShield, but in an open source approach. So mod security was born in 2002. It was and still an Apache module. The design is very interesting because it's very related to Apache. Basically, all of the features of mod security, even SecLang itself, everything is based on what Apache could do at the moment, and the Apache's directive engine and the APR libraries. Then in 2003, we have something that actually changed what will be the future of WAF. That was the OWASP Top 10. OWASP Top 10 defined for the first time a list of which were the risks that we were seeing right now in the internet, and the web in particular, that are affecting most of the companies and people. So it started with a list that contained the things that we all remember in the past, because we will go through that, but OWASP Top 10 has changed a lot based on the evolution of the web. But those top 10 risks that were documented by the team created the standard that was used later to define what was required by a web application firewall to protect the web. So then it came WAF, which also is it's a standard developed by OWASP and the WASP organizations. So it's a document very well detailed about how a WAF should operate. It talks about the deployment, SSL termination, compression management. It talks about which kind of vulnerabilities should be analyzed, also which content types. The document is from the 2005 year, so right now it's not up to date. It's not up to date, but it's really until now it's a great starting point for a WAF if you update it with the new content types and HTTP more 1.1.
Yeah, there is a version 2 in the making. Of course, it's an OWASP project. The document is out there, so you can read it, but it's not complete, and I think it's a long work still having a version 2, which should be adding a lot of the changes since 2005, and probably needs to be covering lots of the aspects of the evolving web from 2005 until now, which are a lot. Yeah.
Yep. So, well,
and to end, there is history on the CRS that we couldn't. You cannot find them because it was in an internal SVN, which is lost in the memory of the internet. Unbelievable, but it's not out there. But there is a public release that you can see in GitHub, and that was in 2013. I remember because I was using it at the moment that it was a SVN version, but not on my old discs has it, and I don't think it's around there anymore.
Actually, there are records that the CRS was released with the first version of mod security, but it was a private project. Okay, so first we're going to start talking about mod security.
Yeah, I can. So the first open source WAF, mod security, it was, as Juan Pablo said, it was designed as an Apache module. So relying heavily on Apache brings you some limitations, right? The things that we know of faces right now on the rule set is basically the places where you can put a callback in Apache, so Apache will call back the module mod security. So that's why we have phases 1 to 5, which is historical. And for example, there are many cloud providers that have way more phases than these 5 limited phases. And this was because of the initial design. The initial design was really focused on Apache and so on. But the thing is that with mod security and the actual module, and because we needed to use Apache configuration for definitions, a new language was born, which is now known as seclang, which is basically a default de facto for doing these WAF configurations in the open source world. It is not the only one. You can use other similar languages that cloud providers provide. But it's basically one that you can talk about with other people, and more or less they will know what you're talking about. The main problem with mod security right now, and since some time ago, is basically we are reaching end of life in 2024 and end of support in 2024. So this is a problem for the open source community because the main product or project used for this is basically hanging out there without any future as we see it now, right? We can say that there were attempts by the OWASP Foundation to speak with Trustwave for getting to know what is going to be in the future with the project and trying to get it more or even into the umbrella of the OWASP Foundation. But those talks still are, we need to keep talking in the future about this because there is no clear definition about that. So right now we are in a limbo and we don't know what's happening with that project, basically.
Okay, so one of the paradigms or patterns that had to be defined during the early ages of the internet was which were the implementation techniques for web application firewall. So at the time, there were 2 major concepts, which were inline and out of band. Basically, inline, you will have your application inside a router, a web application firewall, a transparent proxy, a reverse proxy, or even part of the web server. And out of band, where you will do something probably like port mirroring and asynchronously handling the requests. We already went through this, so.
Yeah.
Okay, so something important I will add about the OWASP Top 10. The OWASP Top 10 did shape the future of the WAF in the early years because it defined what had to be protected. But it was designed with ideas on the Web 1.0. We're going to go through the concepts of Web 1.30 and 2.0. But the main idea is that if you notice, the vulnerabilities that used to be critical 20 years ago as some of them are not found easily because of technology change, or just they're not as dangerous as they used to be. So
the core rule set. Well, with the creation of a WAF engine, was the idea that came from the creator of the WAF engine is, okay, the engine is something that it's ubiquitous. It should be everywhere. It's like right now, you don't challenge the idea of, for example, IP tables, right? You have some module, you have a way of expressing rules, but then you're creating your own rules for that. So the engine should support that. So with the idea of having an engine for doing this, there was the idea of what is the minimum amount of things that we should cover in a rule set for doing a protection that it's going to cover most of the problems we are seeing this in the OWASP top 10 and in other places, right? So with that in mind, the core rule set was created. Right? Initially it was created inside Trustwave or SpiderLabs at the moment. And then it was handed over to the community. And we right now have the OWASP Small Security Core Rule Set, which is this project that we love. And basically at the moment, on version 1.0 of the core rule set, there was some of the rules that were there are really lost in time, as I said. Really, the first rule set that we have is the only thing that we have in GitHub, which is 2.2.
And there was no live injection.
Oh yeah, and there was an only.
Yep. Okay, so we're going through the concept of how all this Web 1.0 brought us to Web 2.0, and which brought us to new technologies and new data types. So everything started with rich content application, Ajax. I know most of you remember the ActiveX modules for Ajax, which will consume the Microsoft XML libraries to provide rich content to the web, and you will get hacked. Definitely. So that evolved into more complex data types like JSON and RPC, which provided new capabilities to the application like live data, which means you will have live content in your application. You could update your content each second or each few milliseconds. And it provided the front end with the ability to perform some logic validation. But as you know, you shouldn't rely too much on your front end. So it brought us to this. Regarding blocking models of the Web 2.0, rich content provided data structures like JSON, but vulnerabilities were a bit different because, for example, cross-site scripting will now be sometimes blocked by frameworks like Angular or Vue, and attackers had to focus on something different. So we started with a focus on cross-site scripting, XXE, XPath injection, but today you won't see those kind of vulnerabilities. It's strange to see XPath injection, even though we have so many rules to protect against it. Today we have a focus on broken object level authorization. We have a huge focus on what is business logic for the application. So also WAFs have to get used to it. So with Web 2, there came new integration patterns. We are going to go through all the kind of implementations that can be used to create a WAF right now. And those are not supported by Coraza, but they are the general in the market, how a WAF could integrate into your app.
Yeah. So eBPF is kind of I will not say a revolution, but as you can run things on the kernel, it's very tied to the kernel and it's very fast. So there is a lot of things that are being run using eBPF, notably lots of observability tools, lots of security tools run using eBPF. And this brings a lot of possibilities because you can go in a crazy speed, but also you can access many of the internals of the many things you're using for executing at the HTTP level, right? We can also read encrypted traffic, which is super interesting, but we have challenges. For example, whenever we have a problem in the specific and with the rule, and we want to terminate the connection, then we have a challenge of actually doing something at the eBPF level. So this is a very interesting, it's very powerful, but then we don't have all the tools yet to just do an interruption and just cut some traffic that is malicious, and we have a rule for blocking, right? So it is challenging, it is super interesting, and it's out there for us to use.
Yeah, and there are many research around how to terminate traffic through by using eBPF, but no one has already reached any pattern that could be used to really block the attacker instead of just reporting the attack. Okay, so regarding tracing, I guess you must have heard about how traces work. So traces are a concept of how you take some data from an application with some metrics or some information. You send it to a collector, and the collector will perform some post-processing of that data. So what's interesting with this is that all current web servers and frameworks are supporting open tracing standards. So you could actually take some collector to retrieve the data directly from your app and perform some web application firewall checks. So if you already have, for example, Kali Web Server, it has an automatic tracing mechanism. So you could just send it to somewhere with a web application firewall, and it will read the JSON structured data and take some action as a publication firewall. And also as eBPF, it doesn't support blocking because we are working asynchronously.
Yeah, gRPC. Well, I think it's been around for some years now. The good thing is like a crazy fast protocol that you can use for doing basically request and response. The RPC is been around for decades, so this is not a new idea. But the idea is that new protocols like gRPC allow you to do a lot of information retrieval in a very fast way. So this is an interesting idea to leverage for communicating HTTP web servers with additional tools that will enrich what the HTTP server is doing. So right now, you can add a gRPC for querying your own backends, for querying your proxies, but also why not to query a WAF to expect something and maybe block whatever you're trying to do in a petition afterwards, in a request afterwards. So this is super interesting, and it's just out there, and it's really achieving very good timings. And also you can interact with different services written in any language. So this is really a very interesting tool to leverage for doing and complementing what we are doing with a WAF.
Also, as a personal opinion regarding this, I think gRPC right now is probably one of the best ways you can integrate a WAF into your network without affecting your infrastructure. Also providing horizontal scalability capabilities. So it's a great opportunity to check gRPC for your WAF. SPOA, it's a complicated topic for Coraza because we do have an SPOA connector, and so many people love it, but we don't know how it came to work. But the SPOA is a protocol created by HA Proxy, which allows us to exchange information from HAProxy. So basically, HAProxy will send the WAF information using this protocol, and the agent will return a list of variables. So the HAProxy implementation can decide whether to continue sending the data to the customer or to the user, or let it pass. It's a great protocol for WAF because it's not easy to extend HAProxy using the C wrapper. So also the great thing about SPOA is that it supports the same load balancing features as backend on HAProxy. So you can have 10 instances of web application firewall and balance them using the HAProxy configuration. Something that sounds a lot in the past few years is WebAssembly. So WebAssembly is a standard that allows us to transform any kind of language, or most of them, into a single binary that's universal. I mean, the same binary, the same code made in Golang or C that you compile into WebAssembly, it should work the same. And it's also being adopted by many projects right now for plugin infrastructure. And the one that's more important for us is Envoy Proxy, which uses as a plugin engine. If you have any questions, go ahead, right? So that leads us to 2023 challenge. Now we have gone through what was the path to come to a web application firewall, but now it is what do we do to solve these 2023 issues with a web application firewall? So one of the first things we have is WebSockets.
Yeah, WebSockets. So the idea is that previous engines are very limited in the sense that they cover mostly HTTP. And of course, the web is constantly evolving. We have seen some time ago been using WebSocket, which is basically designed to work over the same ports, but with an upgrade on the protocol. And then suddenly you have bidirectional messages between the server and the client. So this is very useful for things like real time, both sending audio and video, but also is very useful for having an API, which is actually streaming information between client and server. So we have two different options here. So even when the transmitted data is not standard HTTP, then data might be just a stream of JSON files, right? Which is very common, actually. Like 80-90% of the traffic we are sending is probably that. Of course, we can have audio messages, we can have video, we can have others, and any binary. So the question is, can we protect WebSockets? It's something that is used a lot. It's not used. So this is a challenge for us. And we think that we should be trying to solve or go towards solutions for this problem.
And also a great problem we have with WebSockets. Well, the main problem is that there's no standard data structure. Basically, you can stream binary data or you can stream JSON message. But other problem is there are no wrappers for WebSockets. For example, if you go to Nginx, in Nginx there's a module that takes care of this, so you cannot extend it. If you go to the Caddy server, it's also part of a module, so there's no API to control it. I haven't seen yet any web server API that provides access to WebSockets. So it's something that someone should sometime
focus on.
Focus, right. GraphQL is it came to stay. It's basically a JSON structure that comes with a list of variables and with a query. So it's sent to the server. And the server, instead of an API request, You send like a query with the fields that you want and the variables for the query, and then you receive all the variables you asked for. There are a lot of GraphQL vulnerabilities. It's really easy to mess with GraphQL. So it is something that for this time for this period, we should be thinking about. I mean, all WAFs should support GraphQL. Also, if you right now send a GraphQL query to some web application firewall, like mod security, the only thing you're going to see is a list of JSON fields, and the whole query will be only a string. So we cannot parse it and we cannot process it. The idea is that we can transform it into variables. And a super important problem that I think that's like the biggest problem on web application security right now, it's edge termination. So we went through a lot of techniques and implementations of web application firewall. I'm aware that most of you, the ones who know, you implement inline WAF, so maybe it won't look so much like as a problem. But if you look at enterprise applications that cannot add 1 millisecond because of a web application firewall, they cannot take that luxury. WAF processing must be performed asynchronously. We cannot add more load time to our requests. We're talking about super sensitive services. So how do we handle this? There are many patterns that are being researched right now and many techniques, but there is no general recipe. Basically, you have to see what you have and what you can do with what you have. There are cases where you can use the WAF to actually contact your firewall and block the IP address. There is some people that are brave enough to send reset package to the TCP streams. There's people who will access Redis and delete the session, or you can send information to a SIEM solution and wait for the SOC team to do something. But there is no standard pattern. And I really think this is something that should be an important conversation for web application firewalls.
Yeah, that's adding on top of that is basically something that integrators, this is a problem that integrators are going to have, because whenever you start adding complexity to what you're doing, normally you will need more computing power. And when you add computing power to things like, for example, you have a cluster of machine learning or AI or whatever you're executing in your background that will speed up or lower down your false positive rate in an automated way, suddenly you cannot execute that in the middle of the stream because that's a very heavy process probably, or a very heavy cluster or whatever. So that's why we're mentioning the edge termination, because this asynchronous process is evaluating maybe CRS, but it's maybe evaluating other things like your threat information that you have as a provider or you get from outside, or additional sources of information that you're then condensing in just one result of what should happen with this particular request. So then suddenly you have this bunch of things that you're checking, and you need to terminate that HTTP request in some way. So this is a discussion that is coming. How do we do this?
This is an interesting thing. So cross-site scripting is not fun anymore. In the past, we used to do like, hey, cross-site scripting, now I have your cookies. Now you won't get the cookies because probably the cross-site scripting will be stopped by the browser, or there are security settings that won't allow you to retrieve the cookies, or else. So cross-site scripting has stopped for most of the cases being as dangerous as it used to be. Also, frameworks like Angular or Vue, they will also abstract you from this. So basically you will bring HTML content from an API request, and you won't render the HTML without an explicit instruction to render the HTML. So it's not as strong as it used to be. But the idea is it is not only about XSS, XML, external entities, and lots of attacks that has stopped being so important. Even SQL injection has dropped. You remember when everything used to be SQL injection vulnerable? Right now, there's no framework that allows you to run raw queries easily. You have to hack into it to run raw queries. And horizontal scaling. So something very important from WAF. So in the 20th paradigm, we used to talk about how WAFs require to scale vertically by extending the resources. Like in mod security, if you want mod security to be faster and handle more requests, you add more memory and CPU. The idea of these asynchronous patterns, or also synchronous patterns with external services like SPOA, is that you can perform horizontal scaling and fitting the needs of microservices infrastructures, or also service mesh and complex auto-scaling services. Like if you have a service that will auto-scale, will it auto-scale with your WAF embedded? Or would you have another auto-scaling structure for your web application firewall? That's the question we're trying to solve. And the question for everyone, even for CRS, 0 false positives. Actually, you changed my mind. I changed a lot my perspective with the phase paranoia 0 thing. Yeah, there's no paranoia 0 thing. I mean, also there are certain patterns that we will always be 99% sure that are attacks. But the problem is it's probably less than 1% of the cases. So how do we go generic enough to cover most of the things, but not too generic to avoid false negatives? Also right now, as you can see, we rely mostly on signatures. So what are the steps to go through this? Machine learning, where should we go?
Yeah, we need clearly to enrich what we're doing. Of course, when we're talking about, for example, the core rule set, that there's the idea that once you get on paranoia levels upper than 1, then it's certainly you're going to have more false positives involved. But then you do that at the cost of having less false negatives, which are the ones that you never have. You should never have a false negative, right? And you should catch all the attacks and let pass anything that is not an attack. So in this difficult topic of getting the right threshold on where do I put in my sensitivity levels, which is basically what we are trying to do, is how do we enrich whatever we are doing to lower the false positive rate without compromising on security. Yeah.
Well, now we come to API security. So as I mentioned, API security is something that came with Web 2.0. Now we have more things to analyze. In the past, we only had the request body and the query parameters. But now the path itself are variables. So yes, you can inject data using a path, and you can even perform SQL injection in the path. It's crazy, but sometimes it works. So it adds to the paradigm the use of the path as part of the arguments of the application.
Yeah, and the other thing that with API security is, for example, CRS is a generic thing, right? So it will act mostly on anything that is web. But then APIs are sometimes very, very focused on small things. And most of them are JSON-based. And some of the rules that you have in CRS are XML-based. And you are checking a lot of things that you might not need. So we need to adapt the engine and the rules to be able to be dynamic in a way, or being able to focus on API security only if you're only using API security. right? So this is a very interesting challenge we have in 2023. Well, we have it before, right? But now we are just taking a good look at it, and it's impacting not only in the engine, but also in how we conceive the core rule set and what we can do for getting more speed or more easy generation on the things we are trying to protect on API specifically.
Yes. Yeah, well, and the other topic is how do we compete against CDN WAF? Because everyone is using a CDN right now. You have Cloudflare, or you can have any kind of Fastly or anything you want, like Akamai. But and they provide WAF features, but they are not web application firewalls. So probably most of them runs a core rule set and with enough tuning to provide not too many false positives. So the thing is, how can we look good enough to make someone that will answer us, hey, I already have a WAF from Cloudflare. How do we tell him that he could do better, he could have more control over his WAF? And another important topic is how do you associate a behavior with a user and not the IP address? If you review the documentation of mod security, the default settings for persistence are IP address plus the user agent. It's not something that will track a user. A user can randomize his user agent, and you can track him by IP, because if you track him by IP, you will also be affecting other users on the same network. So if there's a corporate network and many people are sharing the same IP, you will just block them all. So that's a paradigm that we also have to solve. How do we create persistence around a person, not a building? And now what we all came to, it was a huge introduction, right? 40 minutes of introduction. So what's Coraza WAF? We're not afraid to say it. We come to replace mod security. Our focus is mostly enterprise, but it's for rich applications. Coraza is high performance. It's meant to handle as many transactions as your server can handle. We do support many connectors. Unlike mod security, they support only Nginx right now, but in Apache for mod security too. We are trying to go to more of a library approach, so you can use it as an HTTP middleware for Golang or directly for a web server. It's got a lot of rough testing. There are many companies right now working on tuning Coraza and implementing Coraza, so it's been tested against environments with billions of requests. It's completely compatible with the OWASP core rule set, and this is our mascot, Sancho. I added some GitHub stats, so you know what's the status on GitHub. So right now we are 6 active developers, 2 co-leaders. We have 890 stars, 610 commits, 116 forks, 640 issues solved, more than 600 daily clones, and 60 new visitors per day. It might not look like a lot, but for an open source project that is a niche, I mean, web application firewalls are niche. It is really cool. I will go a bit through the technical internals of Coraza. So, as Felipe mentioned, mod security is highly connected to the capabilities of Apache. But if you go around this, Apache capabilities for proxying are really more natural than they seem like. So basically in Coraza, you start by processing a connection. A few days ago, we added a new one. Now we are also processing the host name. Because some RFC says that a reverse proxy should remove the host. So we have found that many implementations have to manually add the host. So we thought it would be cool to add it to the flow. Process URL. This is where we take the URL from the server, the request line. It has the request method. It has the URL and the protocol version. So here we do the parsing of the path to retrieve any variables from the path if there's any. We also take the query from the query string. We take all the get variables. And then we add the request headers. And in process request headers, we do a processing of URL and all the headers. Many people has talked about this of processing by part and adding. I mean, you could add more phases. You could process the URL, but in terms of implementation, most proxy APIs will at the same point in time provide you with the URL and the headers. So if you have them both, let's work with.
Yeah. So the idea is that we're trying to be more. So all the phases that you used to have in most security, which are basically 5 and limited, and there's no change on that. We are trying to be more making phases the first citizens for Coraza. So the idea is that you can add into you can add phases at will. So for example, as soon as you want to block something, you can create a phase for that. Right? For example, you could add something that blocks at the connection level. Right? I just get the IP and the port, and then if I don't like it or I have a rule for that, I can block. That's it. So the idea is that acting as a library and allowing you to interact with that and getting phases created on demand, which we don't have right now, but it's planned, then this is extremely powerful because you are in control and you can decide when to block and why to block. Right? So this is one of the things that when designing this is like, no, we need to provide more so people can use that in their own way and integrate that better than the scheme and fix most security phases.
So, well, similar to security, you will process the request headers, and here we will be on phase 1. Request body, add request body is also disruptive because, well, if there's a setting in mod security that if you pass the request body limit, you can block. So that's why this action is disruptive. And process request body. There we will do the body processing of the data type that we have, add the response headers, and process response headers. Process response headers also receives the response status and the response protocol. Add response body, which is also disruptive, and process response body, logging, and we finish. In the internals of Coraza, Coraza has a modular. Go ahead.
Yeah, it's just for the sake of the recording.
Just a question about content that has multiple. For example, a body that has a multiple part and has mixed content. So you have HTML and JSON. How do you split it and handle it with their different contexts?
You mean HTML inside a JSON or JSON inside an HTML?
Both.
Or
a multi-part that you may have a file and you have.
No, multi-part is supported. You can have anything in a multi-part. It will be parsed by a different parser.
But there is a PR on that. I don't remember who created it.
No, that's a different one. But if you have a multi-part, then each part will be parsed with a different parser corresponding to the multi-part. So the parser needs to exist. If there is, for example, if you have GraphQL, there is no GraphQL parser. So it ends as a JSON or as a text plain or something, and then suddenly it will hit like half of the CRS rules. But because you don't have a specific parser that will create variables for you to to predicate in your rules, right?
Yeah.
But the supported cases, HTML, multi-part, URL code, and so on, those are of the box.
Yeah, but someone created an issue in Coraza. It's really detailed on how we could.
That was Walter.
That was Walter.
I think that Walter, our co-leader. So we were discussing this in the CRS. It's like we are seeing recently. We are seeing a lot of requests that have
mixed content type.
Mixed content. So there is a part that is HTML, but inside you will have JSON or crazy things inside each other, like JSON with HTML or other things inside. So then you need to have a parser that gets the whole structure, and you need to do a sub-parse of the specific line. If not, you will get false positives a lot. So we have one. It's very interesting. And clearly we need to handle this. Is part of the 2022 problems and challenge we are talking about. Yeah.
Yep. Actually, I love that issue. Once V3 is released, I will totally take a look at that. Okay, so we have a modular architecture. When we split Coraza across multiple structs or interfaces that work alone to provide a simple API that only provides access to WAF and configuration. So basically, you can only create a configuration and a WAF. And from a WAF, you can start creating transactions. It's very different from the multi-security model, but it's really a modern approach on how a WAF should work on the year 2023. We're going to see the details in the next few slides. This is a sample implementation of Coraza. I think I will have to someone. Anyway, can you read it? Is this right, or it's not big enough? Okay, mira, aquí.
No. Does it come in plus? No.
Well, so Coraza uses an immutable pattern. So you basically create a new WAF by creating a new config, and this new config has a set of instructions that can be used. You could literally change any of the directories using the helpers, or you can go directly to the with directives function, will give you access to evaluate mod security stack language. You can look for errors in the result, and then you have a transaction. A transaction is born from any WAF instance. This is super crazy about Coraza, but we have to force the logging and closing because Coraza uses many optimizations of memory, something called sync pools that we use to. So many transactions are created in a big environment. So sync pools allows us to reuse them instead of than reallocating the memory. So we recycle the transactions so we can keep using them and save memory allocation. And then we start with the functions that we showed before: process connection, process request headers. And in each one of these processes, we have an object called interruption. Interruption is an struct that tells the web server how to behave. And the web server has to take the decision whether to apply it or not. For example, it could be deny the connection, redirect the user, or pause if you want to implement that.
One of the coolest thing that you have here is that you can actually write a test for whatever you want, right? This is Go, this is plain Go. You have a library and you can write a test. So whatever you're trying to achieve, you can write a Go test for it. And this is really quick and simple. It's a very quick and simple way to try whatever you're trying. Is this rule going to block or not? Is this process, I have this specific pattern. Is this going to work or not? Bam, fire rules. You copy this, you write a test, Go test, and we'll give you the result.
Yep. Actually, Coraza is really highly tested. We have literally thousands and thousands of tests. Benchmarks. Benchmarks are a bit corrupted, these results, because we are talking about mod security, lib mod security using a CGO wrapper. But in case of CGO, if you implement a mod security in Go, Coraza is 40 times faster. It's really a huge difference in terms of implementation. Some deployment options. WebAssembly is something we have been working hard in the past few months. It's super interesting because it's a binary. As we told you, it's a binary that's universal. So basically, you take it from Go and you can ship it anywhere. And there are some connectors that are being developed for Envoy. It's native right now. But there are experimental implementations for Nginx and Kong that you can use to invoke what's called the WebAssembly proxy, WASM proxy, which is a standard that was developed to design proxy modules in WebAssembly. So basically, you transform Coraza into a universal proxy module. The project name is Coraza Proxy WASM, and you can, right now it's the most stable implementation, I think, for Envoy. And you can even embed it in HTML. You can actually run Coraza in your browser. We will actually show you. Caddy module. Caddy module is super interesting because Caddy is a modern web server it's a direct competition for Nginx and Apache. It's super fast. It's super stable. It's undergoing a huge development. The team around Caddy is actually great. And Coraza has a module for Caddy. So if you really want to try it, it's really fun to try Caddy. Also, it's a nice server because it also supports automatic TLS provisioning. So basically, you just start the server and you immediately have a TLS certificate from what's the name? The free certificates website. I don't remember the name. HA proxy through SPOA. And this is a fun one. We were discussing it during the lunch. HA proxy. So there are some enterprise companies using Coraza and some governments that are using Coraza as an SPOA proxy server. So we tried to emulate what they did and created our own version, but it's not going through much development and it's a bit stuck. The problem is that many people are using it and they really like it, but it's something we want to develop, but we can't find some maintainer. But it's really something fun to try. I mean, you can literally have HA proxy without installing anything else, working with a WAF. And in application, standard HTTP middleware. So what's great about this is if that you have a web application written in Go, if you have an HTTP middleware using the native HTTP, you can just use the Coraza wrapper with one line. You will have Coraza working. Also, if you're using Gin framework or HTTP Mux or any framework, the HTTP middleware will work for you. So if you want to embed some WAF into your application, Coraza will be the best choice. Our flagship. I think if you ask me what's the difference between Coraza and everything else, it's extensibility. So we have managed to transform almost everything into a plugin. So operators can be extended. Basically, you can take an operator and make it perform some new validation over data types. You can create new actions with new disruptive actions. You could log to remote servers. You could add new transformations. You can create a GraphQL body processor. You could transform your audit logging to some direct connection to Elasticsearch. So the possibilities with Coraza are infinite, and implementing a plugin is just a few lines.
Yeah, we made we carefully made the design interface on each of the things we are handling in Coraza to be as easy as possible to replace and to use. So you can basically create anything new from it, and it will be very easy to implement and add to Coraza. So the idea that you can have an easy interface and you can actually use it for bringing something quickly, for solving your problem, is really powerful. And basically, it's along the lines of the extensibility on any of the projects we are managing now.
And regarding the roadmap, and this is something really crazy because all of us have different opinions of what's the future of the WAF. But I think this is a list of things that we want to make in the short term. So persistence is something we have discussed a lot. So have any of you worked with mod security persistence? Yeah? Yeah? Yeah, so are you aware of the race conditions? Yeah. Yeah, so it's a great concept. Persistent collection is a great concept, and it's a great feature. You could track a user along the transactions and keep a score. You could do the DDoS validation. You could do a lot of stuff. But the real problem is that it's not properly implemented in mod security. There are race conditions, and also it doesn't solve the problem about horizontal scalability. I mean, if you're going to query a Redis server to get the information for each transaction, you will generate a lot of overhead. So, or if you locally try to change the same transaction and you are a mutex to avoid the race condition, you will force transactions to take a long time to finish. So
I would like to go back a bit. And then not only on the roadmap, but I think that this just created this interesting discussion in how Coraza was originally thought and what was the idea. One of the ideas we discussed a lot in the early beginnings, at least when we started interacting between the CRS and Coraza, was let's try not to do the same mistakes from other projects.
Yeah, let's do this properly.
I don't know it properly, but one of the things that we are trying to do is first talk a lot and involve the community a lot. So the idea is the community should drive what's in the roadmap. One of the things that we have problems with is because, for example, in mod security, to get something merged, it's really a challenge, right? First, you need to implement it properly, and it needs to be vetted properly so it goes somewhere, right? And it makes sense. It makes sense for the project, but then the control, it's on the company. And we didn't want that for this project. So this project was, at the early beginnings, was dancing around a similar problem where there were companies that were interested in this project. And we discussed this a lot, and we say, no, we need to bring this to OWASP, because that's the only guarantee for this project to be alive in the future and be just by the community and for the community. Even though if there are companies working with Coraza and with their own interests, there is no vetting from anyone. So of course we need, but you need to have of only if you create a new feature that it's useful, it will emerge, right? If you have proper testing and there is no other thing than that. You create an issue, you have a feature, you implement it, bam, it's merged. And that's what we were really, really, really focusing on. We need the community for this. So that's why we took this approach. And I think it was, I don't know if it was the best idea, but it was the wise idea in the moment because we didn't want the other thing, right? And I think this is one of the things Coraza has way more useful for the community itself, for the future right now. And this is the roadmap that we have ideas, but it's really open. It's what do you need? What do you want?
Yeah, we're a necessity-based roadmap. Basically, you raise a PR, community thinks it works, we add it.
Yeah, of course, there is a limited amount of developers, so that's the main problem, right? The amount of developers. But if you care about it and if you know programming, then it's up to you.
Okay. We will let the links there. We can come back to the links later if you need them. But I will. This is really cool. This is a super hacker interface because it's black and white. It lacks green. So basically, you can take any request. And then you just run. Error processing. Oh, sorry. There it is. So you can see what match from CRS or from your own rules. You can see all of the collections in a debug status. You can see everything that's inside Coraza. It's a really great tool. But what's most important, this is a client side. This is in the browser. This is WebAssembly. So it's really cool how it works. And it was super easy to implement in the browser, I mean, just a few lines. And it's the same for everything supporting the WebAssembly proxy standard. So there, if you want to add something else, you can host. There you can keep going and adding things, and you can add your own rules. There you go. You see, it's a really way of testing Coraza. It's public. It's on playground.coraza.io. So then you can validate anything around Coraza. You can just type the HTTP request here and the response in here. Because it also supports response. Basically, you can do...
If you have rules in your response, so your rules are evaluating the response, right? Phases 3 and 4.
For example,
there you go.
You could paste a shell in here, or a malware, or something. Great. Questions?
Can you bring us the mic? Sorry.
I had a question to start with on the topic of WebSockets. I think it's quite an interesting idea to expand into looking at other things. But by definition, a WAF is a device that inspects HTTP messages. So I guess the question would be, do you see that as extending the definition of a WAF, or do you see that as a separate tool, like the Coraza WebSocket Inspector or something? And for other things that aren't WebSockets,
this is BWAF. Beyond WAF.
Beyond WAF.
Yeah, we are looking beyond WAF.
So the next generation firewalls.
Yeah, but the thing is, WebSocket is still HTTP. It's encapsulated into a persistent HTTP transaction.
But isn't it just a bidirectional TCP? It doesn't actually use...
Sorry?
Isn't it just TCP?
No, it's HTTP. It is TCP, but it's HTTP, and inside HTTP, it's encapsulated as a request.
You upgrade the protocol.
Yeah, I really think it should be part of the WAF, but as we mentioned before, I have reviewed the API of all of the modern web service. I have personally reviewed the API for Apache, for Nginx, for Kadi, for Envoy, and for everything. And I haven't yet found any point I can hook to take control of the WebSocket. There's nothing sending me the WebSocket stream. Also, the other problem with the WAF is that if you actually have a WebSocket stream, when do you end the transaction? When does the transaction end?
It's a stream.
Yep.
So that's basically it.
No questions? Well, thank you, everyone.
Yeah, I think it's we did good. Yeah, in 5 minutes we have a coffee break. And then last words.
Yeah, do you already have an idea how to solve all the persistence problems? I mean, I've seen that you have that in-app, so middleware functionality. I always wonder if there is a potentiality to work together closer with the application to solve problems like that, or how do you see that?
Well, I actually think that a RASP approach is really great. That would be a WAF inside an app. I think it's a RASP, right? So if you can use Coraza as a library and everything into your application, it will be really great to provide some user tracking features, like using your own application as a data source for persistence. It would be really cool. And regarding persistence in general, it can be implemented, but it needs some reviews. So technically, setvar for persistence transactions supports setting strings, but it should only support setting performing math operations, and only plus and less, because the idea will be that way. We could asynchronously run many transactions over the same user without damaging the data. Because what happens right now is that if you have 100 transactions and you are performing some multiplying operations, at some point you will get the first operation with number 1, multiplying it by 5. And it might be repeated for another transaction, and you will be instead of multiplying the 5 by another 5, you will be multiplying 1 again by 5. So instead of getting a huge number as it should be, you will get a small number because of the race condition. So that's what we somehow have to solve. And using mutex, it's not an easy approach, because if you use mutex, you will have to lock the transaction each time you perform some numerical operations. And if you're using Redis or something like that, it will generate a lot of overhead. I mean, if you want to grow horizontally and you have 10 rules that touches this, and each rule takes 1 millisecond to access Redis and retrieve the data, you will be adding 5-10 seconds of overhead. So is it worth it? I don't know. Coraza is designed for high performance, and I think adding this will be something really crazy. But we have to solve it. Also, there's many people interested in rate limiting, and rate limiting does require persistence.
Yep.
No, the WAF is not the best place to do that. Yeah, the user is wrong. Yeah.
Yeah, no, the idea is that, again, provide things. So if you want to use it, it might be there, but it's your option. If we have people that wants to implement that, that's fine. Rate limiting, I mean.
there will never be a solution to solve all those problems like persistence in a high performance way. I think if we want to scale horizontally, there needs to be some communication between the two, the various entities, right?
Yes.
So you need to have an asynchronous solution for that.
As everything in life, you need to choose two of three, right? And that's a very reasonable thing. You might be able to have it, but it's not going to be as fast as it should. On the other hand, you might just want that, and then you tolerate the slowness.
Yeah.
And that's fine for you. So if we can provide that, then it's fine for you. And even if it's slower, then the idea is that we should not limit ourselves.
Mm-hmm.
Yeah. Again, everything is a plugin. If you require that, you compile that yourself and you can use it. But if not, then it doesn't need to be there slowing anything. So that's the idea.
Mm. Thank you.
Okay. Well, I think we just go for coffee and yeah. I think we need it.